All right, today we're going to be talking about Chapter 1, Lesson 7. This is going to be Part B. We're going to be doing addition and subtraction with scientific notation. Now, addition and subtraction with scientific notation is going to be slightly different and a little bit more difficult. So, whenever we are going to be looking at addition and subtraction, the biggest thing is, and this is the biggest thing, the powers of 10, that's this part here where the times 10 raised to an exponent, have to have the same exponents. And we want to have both be the bigger of the two. So if you look here, we have a 5 and a 6. We want them both to be the bigger of the two, which would be 6. So as we change the exponents, this is important here. Changing exponents. To increase the exponent, you decrease the factor out front. And the opposite would then also be true. So if we want to decrease the exponent, we increase the factor. How we're going to do that is by moving the decimal point. So, however many times the exponent increases, we move the decimal point to the left that many places to decrease the factor. Same thing in the opposite. If we're decreasing the exponent, we increase the factor by moving the decimal point that many places to the right. So let's get some examples here. Example 1, 7.3 times 10 to the 5th plus 2.4 times 10 to the 6th. We want both exponents to be the same. So we're going to want them to both be the bigger of the two. So we want them both to be 6. So this one I'm not going to change. But this one I am. I want it to be 10 to the 6th. So we raised 5 up 1 to get to 6, which means we have to decrease the factor by moving the decimal point one place to the left. So this is going to be 0.73. Now, before you start getting concerned about that number not being written in scientific notation correctly, this is just the process that we take in order to get the correct answer. Because here, increasing the exponent by 1 really means we're multiplying by another 10. So in order to keep everything the same, if we multiplied by 10 here, we need to divide by 10 on this side to keep everything balanced. Add something to one part, I need to take away something from the other to stay balanced. So that's what happened here when I did 7.3 to 0.73. Again, this is not written correctly in scientific notation, but this is part of the process to help us add these two numbers. Now that both exponents are the same, we're going to add the two factors out front. So 0.73 and 2.4. Remember, when we add numbers that have decimal points, we have to line up the decimal points. Fill in any missing spaces with a 0. So 0 plus 3 is 3. 4 plus 7 is 11. So we'll bring down the 1 and carry the other one up top. 1 plus 2 is 3 plus 0 is 3. And bring down the decimal point. So now this is 3.13. And then bring down the power of 10. And the reason why we like going to the bigger of the two is because if we would have went to the smaller of the two, if we would have gone to 5, this number here would not be written correctly. By changing it to the larger of the two numbers with the exponents, this number at the end should be written correctly. unless these two numbers added together gets you more than 10. All right, example 2, same process. I want to look at the exponents. I want the exponents to be the larger of the two, so I want them to be 7. So the one that already has 7 can stay the same. The one that doesn't have a 7 needs to change. So we increase this exponent up 2, which really means we're multiplying by 2 more 10s or multiplying by 100. So in order to keep everything consistent, I want to divide by 100 here, which means moving the decimal point 2 places to the left. So now this is 0.0625. Again, I want to add the factors out front. So this will be 1.7 plus 0.0625. That happens to be 1.7625. And then bring the power of 10 back into this, so times 10 to the 7th. And that is how we add numbers in scientific notation. If we look at the next 2 examples now, we're going to be looking at subtraction. But first thing we need to do here is get this number into B scientific notation. So if you remember all the way back into lesson 6, to convert numbers from standard form to scientific notation, we move the decimal point until we get a number that is going to be in front of the decimal point greater than 1, or greater or equal to 1, and less than 10, which means right here. So this is really going to be 6.45 times 10. Number of places is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be 6.45 times 10 to the 9th minus 8.27 times 10 to the 7th. Exactly the same process. We want both of these exponents to be the same. So we're going to get them to be the bigger of the 2 exponents. So 6.45 times 10 to the 9th is going to stay because 9 is bigger than 7. So I want the 7 to become a 9. Increase the power by 2, multiply by 100 then. So then we want to divide this by 100 or move this 2 places to the left. So this would be 0.0827. Now, instead of adding the 2 factors, we're going to subtract the 2 factors. 0.0827. Now, when we subtract numbers, again, we want them to be the decimal point lined up perfectly, and any missing spaces to be filled in with zeros. Now, I can't take 0 or 7 away from 0, so I have to come over here and start doing the borrow method. I couldn't take anything from 0, so I had to go 1 more. Now, 10 minus 7 is 3. 9 minus 2 is 7. I can't take 8 from 4, so I have to do this one now. But I can do 8 from 14, which is 6. 3 minus 0 is 3. 6 minus 0 is 6. Bring down the decimal point. So this is 6.3673. And then bring in the power of 10 again. So it'll be 6.3673 times 10 to the 9th. All right, last example here. 3.21 times 10 to the negative 5th minus 4.9 times 10 to the negative 7th. Negative 5 is greater than negative 7. So I want to raise this one up to be here. So this number here, 3.1 or 3.21 times 10 to the negative 5th isn't going to change. This one is from negative 7 up to negative 5. Multiply or brought it up by 2, so I'm really multiplying by 100, which means I need to divide this side by 100 or move the decimal point 2 places. So 0.049 times 10 to the negative 5th Same process again. 3.21 minus 0.049. So remember, as I subtract decimals, I need to line up the decimals and fill in any missing spaces with 0. I can't take 9 away from 0, so I come over here to borrow. 9 minus 10, or 10 minus 9 is 1. Now I can't take 4 from 0, but what I can do is come over here and borrow again. 10 minus 4 is 6. 1 minus 0 is 1, and 3 minus 0 is 3. So I have 3.161, and bring down the power of 10. And ultimately, that is how you add and subtract numbers in scientific notation. So this is the end of this lesson. If you have any questions, please let me know.